Hey guys, today we're going to talk about similarity, which is a really important topic in geometry. Um, Similarity gives you two things about shapes. Let's talk about triangles. This is the symbol for similar. Looks like a little squiggly. Triangle ABC is similar to triangle DEF. The order of these letters is very important. A and D are corresponding angles. Angle A would be congruent to angle D. B and E are corresponding angles. B and E are congruent. And finally, C and F are corresponding angles, so they would be congruent. So that's one thing we know about similar triangles. We have congruent angles. Angle A is congruent to angle D. Angle B is congruent to angle E, and angle C is congruent to angle F. Another thing we know is similarity means same shape, different sides. So the sides are not the same, but they are proportional. So AB is proportional to DE. So AB is proportional to DE. That's the same proportion as, for example, BC to EF. And then also AC to DF. What that means is, let me use some numbers to make it easier. What if the sides of ABC were 1, 2, and 3? The other triangle, DEF, would be proportional. So for example, if DE was 3, all the sides of triangle DEF would be 3 times as large, because 3 is 3 times 1. So if the BC is 2, EF would be 6. And if AC is 3, DF would be 9. So let's try some examples from page 508 to see how this all works. So it says for the first couple questions, determine, actually, let's do number 2 first. Here's a word problem. It says Alana has a photograph that is 5 inches long and 3.5 inches wide. So let's draw that. 5 inches long and 3.5 inches wide. It then goes on to say she enlarges it so that its length is 8 inches. What is the width? So here's the enlarged photograph. The length is 8 inches. Now, the photograph, it's kind of implied that the photograph and the enlargement would be similar. If the length goes from 5 to 8, the width is going to increase at that same rate. So one thing you can do is make a proportion. 5 to 8 is the same as 3.5 to what? So we can make a proportion to find this missing side. So small rectangles length to big rectangles length is the same as small width to big width. So we're going to cross multiply. 5 times x is 5x. 8 times 3.5 is 28. Let's divide both sides by 5. 28 divided by 5. Let's see if this makes sense. We get 5.6 inches. Now let's think about this. If the lengths went from 5 to 8, is it believable that the width would go from 3.5 to 5.6? Yes. And one thing you could do to check your work is you can make the proportion again with all the numbers filled in. Is 5 to 8 the same as 3.5 to 5.6? It is. If you cross multiply, 5 times 5.6 is 28. 8 times 3.5 is 28. All right, let's try number 3. Now, numbers 3 and 4 are simply asking us to determine whether the polygons are similar. If so, write the similarity ratio and the similarity statement. So if you look at this first one, B and N are congruent, C and P are congruent. So the side in between them, 66, should be proportional to 99. So let's write that out. 66 to 99. Now that similarity ratio has to hold true for the rest of the parts. Let's see. If 66 is with 99, let's choose the 54, which is next to the 1 slash. That must be similar to the 81 next to the 1 slash. So 54 to 81. And then finally, 40 to 60. Now, all I would do is take these 3 ratios and using your calculator, see if you get the same answer each time. 66 divided by 99. That is 0.6 repeating. 54 divided by 81. Same thing. And 40 divided by 60, you get the same thing as well. So these are similar. And the similarity ratio would be 66 to 99, which reduces to 2/3. Okay, what about number 4? If you look at number 4, it says a similarity statement. A, B, C is similar to M and P. ABC is similar to triangle M and P. The order of the letters is really important. A was the side or the angle that did not have a mark, so that corresponds to M. C had 1 mark, P has 1 mark, and B and N both had 2 marks. So they match up. Let's look at number 4. So let's compare sides DG and HL and DE and HJ. 40 over 16, is that the same as 55 over 22? And it doesn't matter if you went from small to big, as long as you're consistent. 40 divided by 16 is 2.5. 55 divided by 22 is 2.5. So that is also a yes. And basically it's 2.5 to 1, and we went from big to small. So we'll say DEFG is similar to HJKL. Rectangle DEFG is similar to rectangle HJKL. All right, let's do a couple more. What about number 7? Whenever you have questions with nested triangles, it gets a little tricky. So let me write down this diagram. Now these arrows mean that these sides are parallel. 18, 10, 21, M, P, R, and Q. So since these sides are parallel, NP is going to correspond to QR. So M must go here with the 18, 21, 28 is actually MQ. And what are they asking us to find? Find the length of each segment. So you just set up some proportions. Let's call this x. 18 is proportional to 28, just like 21 is proportional to x. To find y, you could do 18 to 28, and then 20, excuse me, y, let's see the easiest way. Well, maybe we'll find this first. Let's see, 18 times x is 18x. 28 times 21 is 588. Divide both sides by 18. 32 and 2/3. So this is 32 and 2/3. Let's see, what else? I guess that's it. MR is, oh, they're asking us to find PR. Okay, we just found MR is 32 and 2/3. We would have to subtract away 21, and that would be 11 and 2/3. They wanted us to find PR. All right, I think that's it. Have a good day, guys, and let me know if you have any questions.